Most organizations think agents means Copilot with extra steps, a nicer chat box, a few connectors, maybe some workflow buttons. They are wrong. Copilot speeds up a human. Autonomy replaces the human step entirely, planning, acting, verifying, and documenting without waiting for your approval. And that's where the fear is rational. The moment a system can act, every missing policy, every sloppy permission, every undocumented exception turns into conditional chaos. The blast radius stops being theoretical because the system actually has hands. So this episode isn't UI talk, it's system behavior. We're going to draw the line between suggestion and execution, define the contract that controls what an agent can touch, and then we'll come back to the uncomfortable parts: identity debt, authorization sprawl, and why governance always arrives late, because that's where autonomy breaks in real tenants. Define the through line, the autonomy boundary. If there's one idea to hold on to for the full episode, it's this: autonomy fails at boundaries, not capabilities. Most people obsess over model quality. They ask whether the agent understands the task. That's comforting, because it sounds like progress is a matter of smarter tokens. But in the Microsoft enterprise, the model is rarely the limiting factor. The limiting factor is the moment the system transitions from I suggest to I execute. That transition is the autonomy boundary. The autonomy boundary is the explicit decision line between two modes of operation: recommendation and action. On one side, the agent produces text, options, summaries, and plans. On the other side, the agent changes the world. It makes graph calls, edits configurations, closes tickets, revokes sessions, moves money, or sends communications that people will treat as official. That distinction matters, because the boundary is where ownership moves. It's where audit expectations change. It's where helpful assistant becomes operator. And enterprises don't struggle because the operator is incompetent. They struggle because nobody bothered to define, enforce, and continuously test the line where operation is allowed. To make that line enforceable, you need a second artifact, the execution contract. The execution contract is not a vibe. It is not a prompt. It is a concrete definition of what the agent is allowed to do and under what constraints. Think of it as a compiled interface between business intent and tool execution. It specifies at minimum 5 things. First, allowed tools. Not, it can use Microsoft Graph. Which graph endpoints, which actions, read versus write is not a detail. It's the difference between reporting and damage. Second, scopes and boundaries: tenant, subscription, resource group, site collection, mailbox, environment, whatever the containment unit is for the workload. The contract names the containment unit and makes it non-negotiable. Third, evidence requirements. What does the agent need to cite before it acts? A ticket ID, an alert correlation, a policy clause, an approval reference, a change record. Autonomy without evidence is just automated guessing with better grammar. Fourth, thresholds: confidence thresholds, anomaly thresholds, volume thresholds. The contract states what safe enough means and when the system must escalate. Fifth, escalation and kill behavior. Who does it wake up? Where does it post? What's the rollback path? And this is the part everyone forgets: how do you stop it cleanly mid-flight without leaving half-applied changes across 10 systems? Now, here's where Altera becomes useful as a concept without becoming marketing. In Microsoft terms, Altera represents the mechanism that operationalizes the autonomy boundary through an execution contract. It's the layer that turns "we want autonomy" into enforceable constraints: tool routing, scoped identities, evidence capture, and predictable escalation. Not more chat, more closed-loop outcomes. And when the episode gets abstract, and it will, this is the anchor. Come back to 2 questions. Where is the autonomy boundary, and what does the execution contract require before the agent crosses it? Because every enterprise failure story in this space reduces to those 2 questions being answered informally once by the wrong person and then never revisited. The contract drifts, exceptions get added, someone needs an urgent workaround, someone else copies that workaround into another environment, and slowly your deterministic intent becomes probabilistic behavior. We'll come back to this later when we talk about identity debt, because identity debt is what happens when execution contracts get multiplied across dozens of non-human operators and nobody remembers why they exist. But before we get to the debt, you need to understand why Copilot can't cross this boundary by design and why that limitation is the feature that keeps most tenants intact. Copilot versus autonomous execution, the non-negotiable difference. If a human must approve the final action, you are still buying labor, just faster labor. That's not a moral judgment, it's a systems description. Copilot is an interface layer that compresses the cost of thinking, drafting, searching, and summarizing. It moves work from slow human keystrokes to fast human supervision. The human still owns the last mile, the click that changes state in Azure, the approval that closes the ticket, the decision that revokes the session, the email that becomes an official instruction. And because the human owns the last mile, the blast radius stays human-shaped. It's bounded by attention, fatigue, and time. That's not great, but it's legible. You can point to a person and say, "This was your decision." Autonomous execution is different. It is not a better chat experience. It is not Copilot, but with confidence. Autonomy is goal pursuit under constraints. The system receives a signal, forms a plan, uses tools, tracks state over time, and keeps going until it meets an outcome condition or hits an escalation boundary. That means autonomy has three properties Copilot doesn't need. First, statefulness. It remembers what it tried, what failed, what changed, what evidence it gathered, and what remains. Without state, you don't have autonomy. You have looping suggestions. Second, tool ownership. Copilot can call tools, sure, but the human still authorizes meaning. Autonomy calls tools because tool calls are the work. Graph, Azure Resource Manager, ITSM APIs, Defender Actions, Sentinel Playbooks, these aren't integrations, they're actuators. Third, multi-step execution with feedback. Autonomy doesn't just perform an action, it verifies. It checks whether the service came back healthy, whether the config drift stopped, whether the incident scope shrank, whether the reconciliation balanced, whether the containment actually contained. If it didn't, it iterates. Now here's where most organizations lie to themselves. They say they want autonomy, but they implement assistance with a longer leash. The agent drafts the change request and the engineer clicks approve. That's still labor, faster labor. It can be worth doing, but don't pretend you crossed the autonomy boundary. You just built a better router for human attention. And the reason this distinction matters isn't philosophical, it's operational. With Copilot, you manage model risk, hallucinations, missing context, bad summaries. With autonomy, you manage execution risk, actual changes in production systems. The failure mode moves from wrong words to wrong actions. And at that point, the only question that matters is who owns the blast radius. In a deterministic security model, you can explain outcomes by configuration. The policy allowed it, the role permitted it, the audit log shows it. In a probabilistic model, outcomes emerge from a sequence of conditional decisions, confidence thresholds, tool routing, exception paths, retries, partial failures, and whatever helpful fallback someone enabled in a hurry. That probabilistic drift is not caused by the model being random. It's caused by the enterprise being inconsistent. The model just exposes it. This is the part people miss. Autonomy doesn't create new governance problems. It simply turns your existing governance gaps into runtime behavior. And that's why identity and authorization become the real cost center. Not tokens, not model routing, not whether the agent sounds smart. When you shift ownership of actions from humans to non-human operators, you are manufacturing new principles, new entitlements, new conditional access edges, new audit requirements, new incident pathways. We'll come back to identity debt later because that's where this breaks in real tenants. But for now, keep the frame simple. Copilot optimizes an individual. Autonomy optimizes a queue. Copilot makes one person faster at doing work. Autonomy makes work happen without that person being involved. Once you see that, Microsoft 365 stops looking like a suite of apps with a chat sidebar. It starts looking like an agent runtime with a massive tool surface area. Graph as the actuator bus, Teams as the coordination layer, Entra as the distributed decision engine, and Purview and Defender as the rails that decide whether the system stays deterministic or degrades into conditional chaos. And that's why Copilot can't cross the boundary by design isn't a limitation, it's a containment strategy. Microsoft's direction, the agentic web is already here. Most enterprises still talk about agents like it's a feature you can choose to enable later, once the pilots finish and the governance deck gets its annual refresh. They are wrong. The direction is already set. Microsoft is normalizing delegation to non-human operators across the stack, not as a sidebar, as the default unit of work. This is the uncomfortable truth. The agentic web is not coming. It is here, and it's being built out as a set of runtimes, protocols, and identity surfaces that make autonomous execution feel ordinary. Look at the signals Microsoft chose to amplify at Build 2025. They didn't lead with better chat. They led with task delegation, assign an issue to an agent, let it spin compute, make changes in a branch, produce session logs, open a PR, and then let other agents review before merge. That is an operational pattern, not a UX pattern. It's also a rehearsal for enterprise autonomy. Because if you can delegate software work end to end, you can delegate everything else that behaves like software, incident response, onboarding, access reviews, finance close workflows, security triage. These are all systems of queues, evidence, and actions. The substrate is the same, and Microsoft is making that substrate explicit. Azure AI Foundry is being positioned like an app server for stateful agents, multi-model, multi-agent orchestration, production observability, and managed execution. That matters because autonomy doesn't scale on prompts. It scales on runtimes. Runtimes give you consistent tool invocation, consistent memory patterns, consistent telemetry, and predictable failure modes. Without a runtime, agent is just a demo that stops working the moment the network blips or the API throttles. Then there's Copilot Studio, pushing multi-agent orchestration into low code, which is a polite way of saying the people who least understand your control plane will soon be able to assemble autonomous workflows anyway. The platform doesn't wait for architectural maturity. It roots around it, and Microsoft is also standardizing the wiring. MCP, the Model Context Protocol, is the clearest example. Microsoft is treating MCP like a universal adapter between agents and tools. And that sounds developer-friendly, and it is. But in enterprise terms, MCP is a force multiplier for both capability and risk because it collapses the friction of adding just one more tool into an agent's reach. Here's the failure mode you need to anchor on. An agent accidentally gains the ability to delete what it should only read, not because the model went rogue, because someone exposed a tool with a broad scope, or a server drifted, or a permission got inherited, or a temporary exception became permanent. MCP makes tool discovery easy. It does not make authorization safe. Discovery is not authorization. Microsoft is even pushing MCP down into Windows itself with a registry concept, user consent prompts, and a model where local capabilities become callable tools. That's not a niche developer story. It's Microsoft telling you that tool access is the new perimeter, and the perimeter now spans cloud and endpoint. At the same time, they're doing something more consequential, normalizing non-human identities at scale. In the keynote language, agents get their own identity and show up in Entra. That's not cosmetic. That's the beginning of an enterprise identity graph where humans are no longer the only operators. Your tenant becomes a mixed ecology of people and principles acting with intent that someone once defined. And when that becomes normal, governance stops being a policy document and becomes a compiler problem. You are compiling intent into enforceable constraints across thousands of decisions per day, made by systems that don't get tired and don't use judgment the way humans do. So if you're waiting for a clean agent rollout moment, you're already behind. The ecosystem is converging. GitHub task delegation as cultural proof, Foundry as runtime, Copilot Studio as distribution channel, Teams as coordination layer, Graph as actuator bus, and Entra as the decision engine that either enforces your intent or quietly accumulates exceptions until you're running conditional chaos. And that sets up the next question. If this is Microsoft's direction, what exactly is Altera in Microsoft terms, without marketing, without mysticism, and without pretending the platform will save you from your own design debt? What Altera represents in Microsoft terms? Most people hear Altera and immediately hunt for the UI. They want to know where the chat box lives, what the agent looks like in Teams, how it shows up in Copilot. That's the wrong axis. The interface is the least interesting part of autonomy because the interface doesn't carry the risk. The system does. In Microsoft terms, Altera represents an execution layer that operationalizes the autonomy boundary through an execution contract. It sits above tools and below business intent. It is the part that takes a goal, a set of allowed actions, a set of required evidence, and turns that into a controlled sequence of tool calls that either completes the work or escalates cleanly. That distinction matters because Microsoft already gives you most of the raw ingredients. Graph, Azure Resource Manager, Defender Actions, Sentinel Playbooks, Copilot Studio Orchestration, Foundry Runtimes, Teams as a coordination surface. The enterprise does not lack tools. It lacks a mechanism that forces those tools to behave like a system. So the clean way to describe Altera is not another agent. It is the thing that makes an agent behave like an operator you'd be willing to put on call: constrained identity, explicit tool access, predictable escalation, and replayable evidence. And you can translate that into a mental model that enterprise people actually understand. Altera behaves like an authorization compiler. You provide intent, resolve these incident classes, reconcile these accounts, contain these alert types. You provide constraints, scopes, thresholds, evidence rules, and who owns escalation. And then that intent gets compiled into a runtime plan: which tools can be invoked, in which order, with which checks, under which identity, producing which artifacts. It is not magic. It is constraint enforcement under load. Now, where does it sit in the Microsoft stack? It sits in the seam between the control plane and the execution plane. Entra, Purview, Defender, and your policy layer define what should be allowed. Graph, Azure, ITSM, ERP connectors, and endpoint actions are how work gets done. Altera lives between those worlds, translating allowed into performed without letting convenience rewrite intent. That's why it can't be just another prompt wrapper. Prompt wrappers make the demo feel good. They do not make the tenant safer. They don't solve identity sprawl. They don't solve tool scope drift. They don't produce evidence you can replay. They don't give you a kill switch that actually stops a multi-system run halfway through. They just produce better sentences about what might happen. Altera, as we're using it in this episode, represents the closed-loop outcome approach. Detect, decide, act, verify, and document as a single executable run. The output is not, here's my reasoning. The output is, the incident is resolved, the reconciliation is balanced, the containment is applied, and here is the evidence trail that proves it. And this is the uncomfortable part for buyers. Altera's value has almost nothing to do with model quality. Yes, you want decent reasoning, but model quality is not what determines whether autonomy works in production. Control plane maturity does. If your identity model is sloppy, autonomy accelerates the sloppiness. If your tool permissions are broad, autonomy turns them into a power tool. If your approvals are ambiguous, autonomy becomes a blame generator. If your audit surfaces are weak, autonomy becomes a storytelling engine. That's why the promise isn't, we'll make the model smarter. The promise is, we'll make the system more deterministic. And deterministic in this context doesn't mean perfect. It means explainable. You can map an outcome back to a policy clause, an entitlement, an evidence artifact, and a bounded action set. So here's what Altera is not. It is not a replacement for Entra. Entra is still the distributed decision engine. Altera is an execution layer that consumes those decisions. It is not a replacement for Purview or Defender. Those are your governance and threat rails. Altera produces the evidence and the action footprints those systems need to evaluate. It is not Copilot, but autonomous. Copilot is a human productivity interface. Altera is an operator runtime pattern. And if that feels like semantics, good. Semantics are where audits live. Because once you accept that Altera is essentially a mechanism for enforcing execution contracts at scale, the next question becomes obvious. Why do enterprises still get stuck at pilot forever? Not because autonomy is impossible, because the first time you try to productionize it, you discover the tenant has no enforceable autonomy boundary at all. Why enterprises stall at pilot forever? The pattern is boring because it repeats. A team runs a proof of concept. It looks great. The agent summarizes tickets, drafts responses, maybe even proposes a fix. Everyone nods. Then someone says the fatal sentence, okay, let's roll this into production. And production is where the tenant's actual shape appears. Pilots succeed because they borrow certainty. They live in a narrow sandbox. A clean data set, a cooperative API, a friendly stakeholder, and permissions that quietly ignore how the enterprise actually works. Then the moment you connect the pilot to the real cues, real incidents, real approvals, real change control, the system hits friction you can't prompt your way out of. The first friction point is permissions. In a pilot, people hand the agent broad access because they're optimizing for speed. In production, broad access becomes a liability surface, and suddenly everyone remembers segregation of duties. The same person who loved the demo now asks, wait, what identity is that running as? And if you can't answer in one sentence, what principle, what roles, what scopes, what conditional access constraints, you don't have autonomy. You have a science project with admin rights. The second friction point is auditability. The demo says, here's what I did. The auditor says, prove it, replay it, show me the evidence chain. Autonomy only counts as enterprise automation when it produces artifacts that survive hostile review, timestamps, inputs, tool calls, approvals, and outcomes tied to policy. If your agent can't produce evidence, it can't be trusted. It can only be tolerated temporarily by people who haven't been burned yet. The third friction point is incident ownership. Pilots have a hero, a champion, someone who owns the agent because they built it. In production, ownership means a pager. Who gets woken up when the agent loops at 2 a.m.? Who approves the rollback when it partially applied changes across Azure Graph and the ITSM system? Who signs off when the agent's action caused user impact but the model's explanation sounds plausible? Enterprises don't stall because they hate autonomy. They stall because nobody wants to inherit a new failure mode without a clear escalation contract. Then comes change control, the quiet killer of agent projects. Autonomy requires updating tools, policies, thresholds, and runbooks as the environment changes. But enterprises treat policy like a museum artifact, written once, rarely revisited, and only updated after an incident. So the agent drifts out of alignment with reality. APIs change, roles evolve, a new SaaS tool appears. An exception gets added just for this quarter. The pilot keeps running with assumptions that no longer hold. And when the first production incident happens, the organization responds predictably. Pause for governance. That phrase sounds responsible. It is usually a confession. It means the organization didn't have an enforceable autonomy boundary. They had enthusiasm and a slide deck. Governance arrives late because it's uncomfortable work. It forces you to make decisions about what the agent is allowed to do, who owns the consequences, and what evidence is required before action. Most organizations avoid those decisions by keeping the agent in suggestion mode, because suggestion mode keeps responsibility human-shaped. This is also where shadow AI shows up. Business units don't wait for central IT. They build agents anyway. Copilot Studio here, a connector there, an MCP server someone found on GitHub, and suddenly actions happen outside the control plane's visibility. Not because people are malicious, because queues never shrink, and someone always wants relief. The platform roots around your governance because the business roots around your delays. So the root cause isn't the enterprise is cautious. The root cause is that autonomy forces the tenant to become honest. It forces you to formalize intent. It forces you to define the execution contract. It forces you to treat exceptions as entropy generators, not as favors. And it forces you to align the control plane, identity, policy, evidence, with the execution plane, tools, actions, outcomes. Pilots avoid that alignment by staying small. Production demands it immediately. And that's why pilot forever is not a maturity stage. It's a stable equilibrium. Assistance feels useful and safe. Autonomy feels risky and political. Therefore, autonomy gets deferred until the next quarter. The quarter never ends. So the question isn't how to do a better pilot. The question is how to design autonomy as a system, not a feature. Because the moment you do, the stall pattern becomes predictable and solvable. The autonomy stack: event, reasoning, orchestration, action, evidence. Once you stop treating autonomy like a feature, you need a stack. Not a vendor diagram, a behavioral stack. How work enters the system, how decisions get made, how actions happen, and how you prove the system didn't just improvise. This is the autonomy stack that actually survives production. Event, reasoning, orchestration, action, evidence. Start with event. Autonomy doesn't begin with a prompt. It begins with a signal that arrives whether you're ready or not. An alert fires, a ticket opens, a mailbox rule triggers, a scheduled job hits, a user reports something in Teams. A threshold crosses in telemetry. The key point is that events are external reality pushing into your system. And this is where people quietly cheat. They build an autonomous agent that only runs when a human asks it to. That's still assistance. Autonomy starts when the system can wake itself up. But event ingestion has an architectural requirement: normalization. If your events arrive in 10 formats with 10 levels of fidelity, you don't have an autonomy pipeline. You have a noisy inbox. So the first job is to translate raw signals into a consistent envelope. What happened, where, to what, and what evidence exists that it actually happened. Now, reasoning. Reasoning is not the agent thinking. Reasoning is the system converting a signal into an intentful plan under constraints. That typically means classify the event, extract the goal, decompose into steps, and decide whether action is allowed. And here's the uncomfortable truth. Reasoning needs explicit stop conditions. Humans stop because they get tired. Agents stop only when you define done or not safe. And without that, they don't become autonomous. They become persistent. So you need confidence thresholds, anomaly detection, and policy checks as part of reasoning, not as an afterthought. The system has to decide upfront whether it should act, ask, or escalate. That decision is the autonomy boundary in motion: suggestion versus execution. Then orchestration. Orchestration is where most people get seduced by complexity. Multi-agent this, planner that, tool router, memory store. Fine. But the practical purpose of orchestration is simple. Route the work to the right capability in the right order, with fallbacks that don't become loopholes. Orchestration chooses tools and specialists the way a human operator does. I need more context? Go query the ticket system. I need to validate scope? Go check identity risk. I need to apply a change, use this runbook. The difference is that orchestration has to be deterministic about permissions and evidence collection. Otherwise, your fallback path becomes the real path because it's easier. And orchestration must handle failure as a first-class input. APIs throttle, graph returns partial data, a device goes offline, a resource group locks, a connector breaks. The agent doesn't get to pretend. Orchestration has to implement retries, back off alternate paths, and escalation rules that don't spam your on-call rotation into quitting. Next is action. Action is the part everyone demos because it looks impressive. But action is where you either enforce the execution contract or you lie about having one. Actions are concrete tool calls: patching a service, updating a configuration, revoking a session, disabling a risky app consent, posting to a Teams channel, creating a change record, closing a ticket. And each action must run under a scoped identity with bounded permissions. This is where read versus write stops being theory. If the agent can write to the wrong plane, you've built a worm with good documentation. So action needs guardrails, quotas, rate limits, scope boundaries, and a kill switch that actually halts an in-flight run. And action must include verification, not I executed. Verified outcomes: service healthy, incident stopped paging, reconciliation balanced, containment took effect. If you don't verify, you didn't automate a result, you automated a guess. Finally, evidence. Evidence is the part that makes autonomy enterprise grade. Without it, you get agent said so, which is just a new flavor of unaccountable change. Evidence means a replayable run. Inputs captured, the event payload stored, the reasoning decision recorded, the tool calls logged with parameters, the identities used, the approvals referenced, the outputs produced, and the verification checks that confirm success. This is not for curiosity, it's for incident reviews, audits, and blame assignment. Because enterprises will do all three. Evidence is also how you detect drift. When the same event class suddenly produces different action paths, you know your contracts or entitlements eroded. So when someone asks, what is autonomy architecturally? The answer isn't an LLM with tools. It's a closed-loop system that ingests events, reasons under policy, orchestrates safely, acts with bounded identity, and outputs evidence you can replay under hostility. Control plane versus execution plane, where governance actually lives. Now, the stack is useful, but it hides the real fight. Governance doesn't live in the agent. It lives in how you separate the control plane from the execution plane and whether you keep that separation intact when someone asks for speed. The control plane is where you encode intent as constraints. It is identities, entitlements, policies, approvals, tool allow lists, evidence rules, and the ability to revoke any of those without negotiating with a dozen app teams. If you can't change the rules without redeploying the agent, you don't have a control plane. You have a fragile app. In Microsoft terms, the control plane is anchored in Entra, your policy layer, and your governance systems, the place where you decide what principles exist, what they can do, under what conditions, and what must be recorded when they do it. It's also where you decide what allowed even means when the actor isn't a person. The execution plane is where work happens. It is the runtime making graph calls, running runbooks, invoking Sentinel playbooks, updating tickets, pushing messages into Teams, touching SharePoint, writing back into the ERP, or performing any other actuator move that changes state. Execution is the part that makes demos look impressive because it creates visible outcomes. It is also the part that turns small mistakes into incidents. That distinction matters because enterprises routinely invert them. They start with execution. We connected it to graph. We wired up the connector. It can restart the service. And then later they bolt on governance, a log file, a few approvals, a policy doc that nobody reads. Over time, convenience overrides intent. The execution plane becomes the real control plane because whoever owns the connector effectively owns the blast radius. This is the uncomfortable truth. Autonomy systems drift toward the fastest path unless you enforce separation by design. So, what does separation look like in practice? First, control plane owns identity, not the agent developer, not the workflow designer, not whoever has contributor in the subscription. The agent runs as a non-human principal with explicitly bounded roles, and those roles live in the same lifecycle as human access, review, rotation, and revocation. If a developer can quietly widen permissions to make the demo work, the system will inevitably ship with those permissions. Second, control plane owns tool availability. Not the agent can use tools. Which tools exist at all, which versions, and which ones are allowed in production. This is where MCP becomes dangerous if you don't treat it like a perimeter. A tool registry is discovery, an allo list is governance. If you don't have both, you will wake up to tool sprawl and entitlement sprawl, and you won't remember which one caused the incident. Third, control plane owns evidence requirements. You don't let execution decide what counts as proof. The policy says, before you cross the autonomy boundary, you must have a ticket reference, correlated telemetry, and a policy clause that permits the action. And after the action, you must emit a replayable record. If you let the execution plane best effort its way through evidence, you'll end up with polite narratives instead of audit artifacts. Now here's the part everyone gets wrong. Exceptions. Most organizations think exceptions are operational flexibility. They are wrong. Exceptions are entropy generators. Every time someone says, just let the agent do it this one time, they're not making the system more useful. They're making your deterministic security model probabilistic. Because the exception doesn't live in a vacuum. It gets copied, reused, inherited, and eventually treated as baseline. The system did exactly what you allowed. You just forgot you allowed it. And the hardest problem in this entire model isn't starting an agent, it's stopping one. Not disable the app registration. Stopping an in-flight run cleanly, mid-execution across multiple systems with partial state changes and retries queued. If you don't design kill behavior into the control plane, you'll learn about it during an incident when the agent keeps helpfully reapplying the action you're trying to roll back. So if you remember nothing else, governance lives in the control plane, not in the agent's prompt. The execution plane will always seek convenience. Your job is to make convenience impossible when it violates intent. The worth it test. When autonomy beats assistance. Autonomy is not better AI. It's a different cost model. Assistance helps a person finish work. Autonomy finishes work and leaves you with an artifact. That means the only honest question is whether the overhead of building and governing autonomous execution pays for itself. And it only pays in a very specific shape of problem. Autonomy wins when the work has volume, repeatability, and bounded consequences. Think of it like any other automation. If the decision is rare, ambiguous, or politically sensitive, autonomy won't save you. It will just give you a faster way to be wrong. So here's the worth it test, stated the way an enterprise should state it. Autonomy beats assistance when it increases outcome throughput without increasing policy violations. Not when users like it, not when the demo is cool. When the system closes more outcomes per unit time, under enforced intent, and humans intervene less without losing control. That test has 4 components. First, throughput. Autonomy is a queue optimizer. If your queue depth never goes down, tickets churn, incidents churn, analysts become routers, then you have a throughput problem, not a skill problem. Autonomy earns its keep when it takes the low to medium complexity items off the queue entirely and keeps doing it at 2 a.m. on a weekend without waiting for someone to look at it. Second, consistency. Humans are inconsistent by design. They interpret runbooks differently. They skip documentation when the pager is screaming. They make temporary changes and forget to reverse them. Autonomy, under an execution contract, does the same thing the same way every time. That is boring. Boring is the goal. Third, 24/7 execution. Assistance still bottlenecks on attention. Copilot can draft the incident report at midnight, but the incident still waits for the engineer who has to approve the change, run the fix, and document it. Autonomy doesn't wait. It executes within its allowed action set, verifies, and escalates only when the contract says it must. Fourth, reduced intervention rate. This is the metric most enterprises refuse to name because it forces accountability. What percentage of cases require a human to step in? With assistance, it's basically all of them, because the human owns the last mile. With autonomy, you expect the intervention rate to drop, meaning the system handles the known knowns and punts the unknown unknowns to humans. Now, those are the benefits. Here's the gate. Autonomy only works when the decision environment is stable. That means the work items have recognizable patterns, the systems involved have reliable telemetry, and the organization can define done in a way that can be validated automatically. If you can't define done, you can't automate outcomes. You can only automate motion. So what passes the test? High volume, repeatable tasks with clear ownership and bounded scope. Common IT remediations. Known reconciliation patterns. Low to medium risk security responses where policy already defines what containment means. Autonomy thrives on operational repetition. What fails the test? Anything with ambiguous policy, sensitive consequences, weak telemetry, or unclear ownership. If the action is might impact executives, you will end up with humans anyway. If the action involves money movement without a deterministic evidence chain, you will end up with auditors anyway. If the signal quality is low and the system spends its time guessing, you will end up with an expensive guessing machine. And the most common anti-case is the one nobody admits, unclear blast radius. If you can't bound the scope of what the agent is allowed to touch, you shouldn't let it touch anything. That's not caution, that's just math. Now the KPI framing, because this is where autonomy projects die in finance meetings. You don't measure autonomy by token cost. You measure it by cost per closed outcome, cost per incident resolved, cost per ticket closed, cost per reconciliation balanced, cost per alert triaged to a real incident or dismissed with evidence. If autonomy lowers that number while holding policy compliance steady, it's worth it. If it only makes people feel faster, it's assistance with extra risk. So track 4 metrics and don't negotiate with yourself about them. Time to close, from event to verified outcome. Human in the loop rate, what percentage required intervention, not review. Rollback frequency, how often did autonomy make a change that had to be undone? Policy compliance, how often did it cross a boundary it shouldn't have crossed? And if you want one more that cuts through the noise, intervention histogram. Not averages, the distribution, because the long tail is where incidents live. If the worth it test passes, autonomy becomes an engineering project. If it fails, keep it as assistance and be honest that you're buying faster labor. Now we can get concrete, because the first scenario, autonomous IT remediation, exposes control plane immaturity faster than any governance workshop ever will. Scenario 1, setup, autonomous IT remediation at scale. IT remediation is where autonomy stops being a philosophy and becomes a liability calculation. Because the pain is real, the volume is relentless, and the work is mostly the same handful of moves repeated forever by tired humans who swear they'll document it next time. The typical enterprise starts here, alert fatigue. Monitoring fires, someone triages, they assign it, the assignee asks for context, then you get the escalation loop. The ticket bounces between teams because nobody owns the whole path. Meanwhile, users keep reporting the symptom, not the cause, so the queue gets heavier while the service gets worse. And buried inside that mess is a simple truth. Most of the incidents aren't mysterious. They're just unowned. They're restart-worthy, rollback-worthy, apply the known fix, and verify-worthy. But because humans are the bottleneck, everything queues. Work doesn't close. It churns. So the baseline flow most organizations run looks like this. Detect, triage, assign, remediate, document. It sounds orderly. In practice, it's a game of telephone. Detect is an alert with weak context. Triage is a person reconstructing context across 3 portals. Assign is guessing who's least busy. Remediate is someone doing the same command sequence they did last week. Document is either an afterthought or a copy-paste narrative written to satisfy process, not truth. Now the autonomy version, the one worth doing, changes the shape of the work. The agentic flow is detect, diagnose, remediate, verify, close, report. Notice what's missing. There's no assign step because the system doesn't need to find a human. And there's no document later because evidence is part of the run, not a chore you hope somebody remembers. But this only works if you take ownership seriously. Autonomy doesn't eliminate ownership. It just moves it. Someone still carries the pager. Someone still owns rollback. Someone still owns the change record when the agent makes a configuration update that technically counts as a change, even if nobody typed the command. So before you let an agent touch remediation, you need to answer the questions most pilot teams avoid because they're inconvenient. What incident classes are in scope? What systems are allowed to be changed? What is the containment unit, subscription, resource group, specific service, specific environment? What evidence is required before the agent is allowed to act? And what does verified mean for each fix? Because in IT remediation, the action is usually trivial. The blast radius is not. Restarting a service sounds harmless until it restarts the wrong tier, drops connections, and triggers a cascade that looks like an outage. Rolling back a config sounds safe until the known good state is from 3 months ago and today's dependencies are different. Patching sounds responsible until the patch triggers a reboot during business hours because someone forgot to encode a maintenance window. This is why autonomy and remediation is the fastest way to expose whether your control plane is real. If you can't express a remediation action as a bounded, auditable, reversible operation, you shouldn't automate it. Not because automation is scary, because automation is honest. It executes what you allow repeatedly at machine speed. So in this scenario, the objective isn't let the agent fix everything. The objective is narrower and more defensible. Let the agent close the predictable incidents that already have deterministic runbooks with explicit thresholds and clean escalation. Think memory leaks with known mitigations. Stuck queue processors. Certificates approaching expiry where rotation is already scripted. Disk space remediation where cleanup is defined and bounded. Service restarts where the verification checks are clear and the rollback is bring it back up and page a human if the health probe doesn't recover. And if you're thinking, okay, that's just automation, good. Autonomy is automation with 3 added requirements. It chooses the runbook, it proves why it chose it, and it verifies the outcome under an execution contract. Now here's the payoff signal you should hold on to. Closing the ticket is easy. Producing evidence and bounding the blast radius is the work. That's why this scenario is perfect as the first deep dive. It forces you to confront the autonomy boundary in a domain where outcomes are measurable and failure is loud. If the agent can't show its evidence trail, you won't trust it. If it can't be stopped mid-flight, you'll fear it. If you can't name who wakes up when it fails, you're not doing autonomy. You're doing a demo. So the next thing is to map the flow across the real enterprise surfaces, Azure for the resources, Graph for identity adjacent actions and communications, the ITSM system for tickets and change records, and policy gates that decide when execution is allowed. That's where most implementations collapse, not in the model, but in permissions and scope. Scenario 1, system flow, Azure plus Graph plus ITSM plus policy gates. Start with the reality. The agent can't remediate an incident. It can only move through systems that already exist. Azure for the workload, Microsoft Graph for identity adjacent actions and communication, the ITSM platform for the record of truth, and then policy gates, Entra approvals, and evidence rules that decide whether the agent is allowed to touch anything at all. So the flow begins at ingestion. A signal arrives from Azure Monitor, Log Analytics, Defender for Cloud, Service Health, or a ticket event from your ITSM tool. The first job is to normalize that signal into something the autonomy stack can reason over. Incident class, impacted resource, environment tag, customer impact signals, and any known runbook mapping keys. If the event payload can't be mapped to scope, the system should not try harder. It should escalate. Autonomy doesn't earn trust by guessing. It earns trust by refusing to act without containment. Next is correlation and diagnosis. The agent pulls additional context from Azure. Recent deployments, configuration changes, scaling events, health probes, dependency failures, and whatever telemetry exists that can confirm this isn't a phantom alert. This is where the execution contract's evidence requirements become mechanical. If the contract says 2 independent signals, the system must collect them. A failing synthetic test plus a spike in error rate, for example. If it can't, it stops. That's the autonomy boundary doing its job. Now, the system decides whether the incident is in an autonomous class. That classification shouldn't live in a prompt. It should live in policy, a list of incident types, environments, and severity levels that are eligible for automatic action. Production CV1 with unknown blast radius? No. Non-prod queue processor wedged for 30 minutes with a known fix? Yes. The goal is not heroics. The goal is predictable closure. Once the incident is eligible, orchestration selects the remediation pathway. In enterprise terms, this is runbook selection with preconditions. The agent chooses restart service, scale out, roll back last deployment, clear poison queue, rotate certificate, whatever you've defined. But each pathway has to include 2 extra things humans often skip: a rollback plan and a verification plan. Rollback is what happens if the action makes it worse. Verification is what proves the action worked without a human saying, looks fine. Now we hit the policy gates. Before any write action, the agent should cross-check identity and authorization, what principal is executing, what roles are active, and whether the current context satisfies conditional access and whatever risk conditions you enforce. And yes, if you're doing this properly, you'll end up with something PIM-like in spirit, even if the implementation differs, a constrained elevation model for specific actions, time-bounded, scope-bounded, and logged as an event that can be audited. At the same time, the ITSM system becomes a gate, not a bystander. The agent should either create or update a ticket with the detected signal, the evidence collected, the planned action sequence, and the policy clause that authorizes execution. If change control matters in your org, the agent should also create a change record, because the agent did it is not an exemption from your own process. It just means the process must be machine readable. Then the action execution happens in Azure. This is where people get sloppy. Restart the service must be implemented as a scoped operation. Target resource IDs explicitly, restrict subscription and resource group boundaries, and enforce rate limits so the agent can't restart the entire fleet because it saw the same symptom twice. If the remediation involves deployment rollback, it must pin to a specific version and validate dependency drift. If it involves patching, it must honor maintenance windows. Autonomy doesn't erase operational discipline. It weaponizes it, either in your favor or against you. Now, Graph shows up for two things: coordination and containment. Coordination means notifications, posting to the right team's channel, updating the ticket, emailing impacted stakeholders if that's your norm. Containment means identity-adjacent actions when the incident demands it, disabling a compromised app registration, revoking sessions, rotating secrets, or pulling access. But those actions are higher risk, so they should sit behind stricter gates, stronger evidence requirements, tighter scopes, and lower confidence tolerance. Finally, verification and closure. The agent requeries telemetry. Health probes green, error rates normal, queue depth trending down, user impact signals resolved. If verification fails, it either rolls back or escalates depending on the contract. And when it closes, it doesn't just close the ticket. It writes the evidence bundle, inputs, decisions, tool calls, approvals, and verification results linked to the ITSM record. That bundle is the product. Without it, you don't have autonomy. You have fast, unreviewable change. Scenario 1. Governance, least privilege, or it becomes a worm. Now we talk about governance because this is where the remediation story stops being an engineering win and starts being an enterprise incident waiting to happen. Autonomous remediation has a simple security truth. If the agent can do anything, it will eventually do everything. Not out of malice, out of pathfinding. Tools try to succeed, retries try to recover, fallbacks try to help. And if you gave the system broad rights, you built a self-propelled operator with no meaningful containment. That's a worm, just with nicer logs. So governance for this scenario is not a checklist. It is least privilege expressed as an execution contract that the runtime cannot negotiate with. Start with the agent identity. This cannot be a service account. It cannot be my automation app registration. It's a non-human principle with a single purpose, a narrow scope, and a lifecycle you actually manage. It needs explicit role boundaries, what it can read, what it can write, and more importantly, where. Subscription, resource group, specific resource types, specific environments. The containment unit needs to be explicit because remediation is always tempted to expand scope. I saw the issue here, so I'll go look over there. No, it stays where you told it to stay. Then you enforce it in Entra and Azure Authorization, not in a prompt. The easiest way to lie to yourself is to implement least privilege in the orchestration logic while the principal still has contributor. The system will behave until it doesn't, and when it doesn't, the logs will faithfully record the outcome you allowed. So you need a pattern where the baseline identity can observe broadly enough to diagnose, but act narrowly enough to not create a blast radius. And if you require elevation for certain actions, you make that elevation time-bounded, scope-bounded, and auditable. Call it PIM-like, call it just-in-time, call it whatever you want. The mechanism isn't the point. The point is that write access is a temporary capability, not a permanent property. Next, permission granularity. Most orgs treat remediation as a single permission set. The agent can remediate. That's how you end up with an agent that can restart a service and also reconfigure networking because both are operations. They are not symmetrical. Restart one app service instance is an operational nudge. Modify NSG rules is infrastructure surgery. Roll back a deployment is reversible. Rotate secrets across dependencies is cross-system coupling. So you define action classes and you bind privileges to those classes. You do not grant write and hope policy saves you. Policy doesn't save you. It records your mistakes. Now guardrails, because permissions alone don't prevent failure loops. You need kill switches, real ones. A kill switch is not disable the app. A kill switch is a control plane decision that stops new runs from starting and also terminates in-flight runs cleanly, cancel queued tool calls, prevent retries, and leave a clear, halted state that humans can resume from or roll back from. Without that, your incident response will include fighting your own automation while it keeps trying to help. Then you need quotas, action quotas per run, action quotas per hour, resource quotas per scope. If the agent sees 500 alerts and decides to remediate all of them, that's not productivity. That's a denial of service you paid for. Quotas force the system to batch, to prioritize, and to escalate when it hits its allowed limit. And you need confidence thresholds that actually mean something, not a single confidence score number that gets tuned until the system acts. You define what constitutes sufficient evidence for the class of incident. 2 independent signals, a known signature, a validated precondition. If those aren't met, the agent escalates with the evidence it has and stops. That's how you keep autonomy from becoming probabilistic improvisation. Finally, the escalation contract. When it can't act, where does it go? ITSM ticket assignment, Teams channel, on-call paging. And what does it include? It includes the evidence bundle and the proposed next action, not a vague summary. The goal is to turn human in the loop into human as exception handler, not human as the default executor. And you measure all of this because governance without measurement is theater. Track MTTR delta, sure, but also track human in loop rate, rollback frequency, and the number of times the kill switch gets used. If rollbacks are frequent, your execution contract is too permissive or your verification is weak. If the kill switch gets used often, you have a drift problem. If the human in loop rate never drops, you built assistance and called it autonomy. So the governance rule for scenario 1 is brutal and simple. Either remediation is least privilege with enforceable boundaries, or it becomes a worm with change control paperwork. There is no third state. Scenario 2. Setup. Finance reconciliation and close support. Finance is where autonomy stops being ops automation and turns into institutional trust. Because reconciliation isn't a convenience task, it's the thing standing between your organization and an audit finding that ruins someone's quarter. The pain pattern is predictable. Close arrives, everyone becomes a human join engine, and the spreadsheet layer metastasizes. People pull exports from the ERP, bank feeds, expense platforms, procurement systems, and whatever temporary tracker someone made because the official system was slow. Then they spend days matching line items, chasing missing references, and writing explanations that sound plausible enough to survive review. And the thing most people miss is that reconciliation work has 2 outputs, not 1. Yes, you want the numbers to balance, but the real product is the rationale. Why this transaction matches that one, why this variance exists, what policy clause allows the adjustment, and who approved the exception. Finance doesn't just need an answer, it needs an answer that can be reperformed under scrutiny. That's why assistance hits a ceiling here. Copilot can draft a variance narrative faster, it can summarize a spreadsheet, it can help a controller write an email, but it can't by itself create an evidence chain that an auditor can replay end to end. And without that evidence chain, autonomy is not automation, it's liability. So the autonomy boundary in finance has to be drawn differently than in IT. In IT remediation, the boundary is usually, can the agent execute the runbook safely and verify service health? In finance, the boundary is, can the agent justify the action with grounded source references and policy alignment before it touches anything that affects a ledger? Because finance failures are quiet. They don't page you at 2 a.m. They show up months later in a room with lawyers. The baseline close workflow looks like this. Extract data, reconcile, resolve exceptions, document rationale, get approvals, post adjustments, report. Humans act as translators between systems that don't agree on identifiers, timestamps, currencies, or the meaning of settled. They also act as policy interpreters because exception handling is where the judgment lives. The agentic target outcome is not replace accountants. The agentic target is shrink the exception queue and turn routine matching into a deterministic pipeline. That means the agent does 3 things well. First, automated matching across known patterns. Same vendor, same invoice ID, same amount, predictable timing offsets. This is boring work, but it's high volume and it's where humans burn time that should be spent on the weird cases. Second, anomaly surfacing with real triage. Not here are 500 variances, but here are the 12 that matter, with clustering. Duplicates, currency conversion discrepancies, partial shipments, late postings, missing purchase order references. The value is not finding anomalies. The value is reducing the search space. Third, auto-resolution for known mismatch classes, but only when the execution contract permits it. For example, reclassifying transactions that meet explicit criteria, generating correcting entries that are pre-approved under policy, or preparing a journal entry package that is complete and ready for human approval when the action crosses a sensitivity threshold. And the blunt line for this section needs to land cleanly. Autonomy that can't explain itself is not automation, it's liability. Because a finance agent that says, trust me, is just a faster way to create untraceable adjustments. The agent must behave like a disciplined analyst. Every number tied to a source, every transformation documented, every decision bound to policy, and every action gated by approval when the consequences exceed the autonomy boundary. Now, let's be precise about systems touched without pretending we're doing a product tour. Finance reconciliation in a Microsoft enterprise will touch at least 3 surfaces. the system of record, the collaboration layer, and identity context. The system of record is your ERP and its satellites, where transactions live and where adjustments ultimately land. The collaboration layer is Microsoft 365, Excel files, SharePoint or OneDrive stores, Teams conversations, email threads that become approvals in practice even when they shouldn't. An identity context is Entra, who is authorized to view, who is authorized to propose, who is authorized to post, and what segregation of duties rules must remain true even when an agent is doing the legwork. And this is where the autonomy stack becomes unavoidable. Events are the close calendar, the arrival of feeds, the detection of variances beyond tolerance. Reasoning is classification and policy mapping. Orchestration is dispatching specialized matchers and anomaly agents. Action is creating the adjustment package or posting within a constrained scope if allowed. Evidence is the entire point. A replayable reconciliation run that survives hostile review. So scenario 2 sets up the real enterprise question. IT autonomy fails loudly. Finance autonomy fails quietly. And that's why in the next section, the product we design isn't the agent, it's the audit trail. Scenario 2, evidence first design. Audit trails as the product. Finance autonomy only works when the evidence trail is treated as a first-class deliverable, not a side effect. Most implementations do the opposite. They build the reconciliation logic, they wire up the connectors, they generate a looks right summary, and then someone says, we'll add audit later. Audit later is how you end up with an agent that can move numbers without leaving fingerprints. That is not innovation, that is a governance incident with better branding. So in this scenario, the product is the audit trail. The reconciliation result is just the byproduct that makes finance care. Start with the required artifacts because finance doesn't accept vibes as proof. Every matched or adjusted item needs source references, the transformations applied, the rationale, and the approval context, not as prose, as structured linkable objects, a bankline item ID, an ERP document ID, a file hash or SharePoint version ID for the supporting schedule, and a pointer to the policy clause that authorizes the treatment. If the agent can't point back to exactly what it used, it can't claim it reconciled anything. It just predicted what reconciliation might look like. That distinction matters because large language models are inherently probabilistic. They generate plausible explanations unless you force them to operate under grounding constraints. In finance, plausible is the enemy, so grounding discipline becomes non-negotiable. This is not a web search problem. This is not, let's ask the internet what GAAP says. The agent must operate on controlled enterprise data sources with deterministic access boundaries. If the system of record is the ERP, then the agent reads the ERP. If supporting documentation lives in SharePoint, then it reads specific libraries with specific labels under specific scopes. And when it produces a narrative, it cites those sources like a hostile reviewer will check them because they will. Now, orchestration, finance, reconciliation looks like one workflow, but it's really a set of specialist behaviors coordinated under a strict contract. You typically want at least 3 conceptual agents, even if they're implemented as one service. A matching specialist. It performs deterministic joins and pattern matches. With tolerances and rules that are explicit, it should prefer boring, explainable logic over reasoning whenever possible because deterministic matching produces auditability by default. An anomaly specialist. It clusters exceptions into known classes, prioritizes by materiality and risk, and flags what cannot be resolved automatically. The goal is not to generate a longer exception list. The goal is to reduce the controller's search space. A policy specialist. It maps proposed adjustments to policy, segregation of duties, approval thresholds, materiality rules, and whatever your organization enforces. This is where the autonomy boundary lives in finance. The system can propose broadly, but it can only execute narrowly and only with the approvals the policy requires. Then a coordinator ties them together and produces a run artifact, and that run artifact has to be replayable. Replayability is the thing most teams skip because it feels like extra work. It is not extra work. It is the only mechanism that converts agent output into operationally defensible automation. Replay means you can take the same inputs, the same source extracts, the same versions of files, the same policy rule set, and rerun the logic to get the same outcome. Or, if the outcome changes, you can prove why. A data change, a policy change, or a tool version change. Without replay, postmortems become storytelling. Finance doesn't tolerate storytelling. So what does the agent produce? It produces variance packs and exception queues that look like finance work product, not AI output. A variance pack that includes the matched sets, the unmatched sets, the transformation steps, and the rationale. An exception queue that includes reason codes, suggested remediation steps, and the minimum approval required to resolve it. And it produces controller-ready narratives that are grounded. Every claim backed by a linked source reference. Now metrics, because you'll be asked to justify this. Time to close for the reconciliation cycle is obvious, but it's not enough. You track error rate versus human baselines, because autonomy that is faster but wrong is not autonomy. You track exception backlog aging because the goal is to shrink the long tail that drags close past the calendar. And you track intervention rate. How often did humans have to rewrite the rationale, not just approve the package? Because if humans keep rewriting it, you didn't automate reconciliation, you automated draft generation. And once you build evidence first, you also get a hidden benefit: blast radius containment. If every action is tied to a policy clause and an approval state, the system can't quietly just post the entry. It either has the authority and evidence or it escalates with a complete package. That's the autonomy boundary, but finance flavored. And it's the only version that survives audit season. Scenario 3. Setup. Security incident triage without SOC collapse. Security is where autonomy stops being a throughput discussion and becomes an adversarial one. IT remediation fights entropy. Finance fights scrutiny. Security fights an opponent that adapts. And that's why SOC collapse is the most honest autonomy use case you can pick. Because the baseline operating model is already broken in most enterprises. Alert volume grows faster than analyst headcount. Fidelity stays mediocre. And every new tool adds another stream of signals that mostly become noise. So analysts spend their day routing, enriching, and writing summaries that don't prevent the next incident. The queue doesn't shrink, it churns. Defender produces alerts, Sentinel produces incidents, Identity produces risk events, Endpoint telemetry produces anomalies, Cloud produces activity logs. None of those are inherently wrong. The failure is the human bottleneck in the middle. A small team forced to do correlation and enrichment manually at the exact moment the environment requires speed and consistency. So the baseline workflow looks like this: triage, enrich, correlate, decide, contain, document. And everyone pretends it's a linear process. It isn't. It's a loop. Analysts bounce between portals, copy identifiers, search for context, and rebuild the same mental model of what happened every time. The attacker gets parallelism. The defenders get a ticketing queue. That asymmetry is the point. So when people ask what autonomy is good for, security has the cleanest answer. Autonomy buys you parallelism under policy. It lets you do the mechanical work at machine speed: correlation, enrichment, scoping, and low-risk containment. So humans spend their limited attention on the weird cases that actually require judgment. But the autonomy boundary here is brutally non-negotiable. A security agent doesn't get to improvise containment. It doesn't get to try something. It doesn't get to block identities or isolate devices because it feels right. It acts only under policy, with pre-approved actions, bounded scopes, and evidence thresholds that are defined ahead of time. Otherwise, you built the most dangerous thing possible: an actor in your tenant with the power to disrupt business operations, guided by probabilistic reasoning during high stress. So the agentic objective in this scenario is narrow by design. Correlate alerts into coherent narratives. Assess blast radius with real signals, not vibes. Contain low to medium risk incidents where policy already defines the response. And generate investigation summaries that humans can trust and replay. That means the agent becomes a triage engine and a response executor for the boring, repeatable cases. Suspicious sign-ins with clear identity risk signals, commodity malware on endpoints where isolation is already standard, impossible travel combined with high-confidence phishing, known bad tokens, known bad device posture. It handles the class of incidents where humans currently waste time doing the same steps, and it escalates everything else. Now, the thing most people miss is that security autonomy fails first when identity is an afterthought. Because containment is mostly identity and access control actions: revoke sessions, reset passwords, disable accounts, block tokens, tighten conditional access, remove risky app consents. If you can't express those actions as bounded, auditable operations under explicit identity constraints, you don't have autonomous response. You have automated self-harm. So you need a hard boundary. The agent can recommend broadly, but it can only execute in the lanes you've made deterministic. And the evidence requirement must be higher than the model is confident. It has to be these signals match this response class under this policy clause within this scope. And the payoff signal for the audience is simple. The problem isn't building the containment action. Microsoft gives you actions. The problem is deciding when the system is allowed to execute them, under which identity, and how you prove it didn't overreach. Because a SOC doesn't get judged by how fast it can generate a summary. It gets judged by whether it contained the right thing without breaking the business. So this scenario is where the autonomy stack becomes visibly real. Event ingestion is alerts and incidents, reasoning is correlation and classification under policy, orchestration is tool routing across Defender, Sentinel, and Entra, action is containment with bounded permissions, and evidence is the investigation record that ties every step back to signals and policy. And in the next section, we map it as an enforcement graph. Defender detects, Sentinel correlates, Entra enforces. If those three aren't wired into a coherent control plane, autonomy won't save the SOC. It will just accelerate the chaos. Scenario 3. System flow. Defender plus Sentinel plus Entra as enforcement graph. If scenario 3 is going to work, it needs a real system flow. Not the agent checks Defender, not it uses Sentinel. A flow where each product plays its actual role in the enterprise. Defender as signal source, Sentinel as correlation and case management, Entra as the enforcement graph that turns decisions into bounded actions. Start with ingestion. Defender for endpoint and Defender for Office generate alerts with raw artifacts, device IDs, user principals, process hashes, URLs, mailbox activity, and whatever else the detection contains. Sentinel ingests those alerts and also brings in everything Defender doesn't own: cloud activity logs, firewall events, identity risk events, and third-party sources if you have them. The agent doesn't treat this as more data. It treats it as a graph problem. Which entities are involved, what relationships exist, and what changed recently. So the first move in the flow is normalization into entities: user, device, app, mailbox, IP, token, session, tenant, resource. If the system can't map the alert to entities, it should not execute anything. It should escalate for human triage because it can't bound scope. Containment without scope is just disruption. Then comes reasoning, correlation, and blast radius estimation. This is where Sentinel earns its role. Sentinel already builds incidents and correlates signals. The agent's job is to query that correlation layer, not to reinvent it with reasoning. It should pull the incident graph, related alerts, linked entities, timeline, known tactics, and severity context. Then it applies an execution contract decision. Does this incident class have an approved autonomous response path? That decision is not a vibe check, it's policy. Low to medium risk classes with clear response playbooks can be eligible. Revoke sessions for a confirmed risky sign-in, isolate a device for a high-confidence malware alert, block a known malicious URL through your existing controls, disable a specific OAuth consent that matches a known bad pattern. High-risk or ambiguous cases get escalated with a complete evidence bundle. Now, orchestration, tool routing. This is the part that separates agent as chat from agent as system. The agent routes work across a set of tools that already exist. Defender APIs for endpoint and email actions, Sentinel automation rules or playbooks for workflow, Entra for identity enforcement, and Graph for communications and ticketing. The key is that orchestration must be deterministic about which tool is authoritative for which action. You don't revoke sessions through a random connector if Entra is the enforcement point. You don't isolate devices through a custom script if Defender already provides the actuator and the audit trail. Orchestration chooses the canonical actuator because that's how you get predictable logs and predictable rollback. Then we hit action, and action should come in two tiers: containment and coordination. Containment actions are the hard ones: session revoke, password reset initiation, user disablement in narrow conditions, device isolation, token blocking, OAuth app consent removal, and conditional access response patterns. Coordination actions are everything that keeps humans aligned. Create or update the Sentinel incident, open the ITSM ticket if that's your process, notify the SOC channel in Teams, and ping an on-call human only when thresholds say the agent can't close the loop. Now the enforcement graph, Entra as the choke point. This is where people get comfortable and then get hurt. They treat Entra as identity, meaning login and users. In reality, it is the decision engine for access across the tenant. When the agent takes action, it should do it through Entra-controlled mechanisms, revoking sessions, blocking sign-ins through conditional access where appropriate, adjusting entitlements through scoped roles, and ensuring the agent identity itself remains constrained. And every action must run as a non-human principal with explicit permissions. Not global admin, not security administrator because it was easier. The system should have separate execution identities for separate action classes, because the moment one identity can do everything, the blast radius becomes the entire tenant. Again, worm mechanics, just in a blazer. Finally, evidence. Every run produces a replayable record. The alert IDs, incident IDs, entity graph, the policy clause that authorized action, the exact tool calls, the parameters, the identity used, the verification checks, and the final state change. And verification matters here: session revoked, confirmed; device isolation state, confirmed; sign-in risk reduced, confirmed; incident status updated, confirmed. If verification fails, the system doesn't try harder indefinitely. It escalates with the evidence bundle and it stops. So the system flow is simple to say, but hard to implement cleanly. Defender detects, Sentinel correlates, Entra enforces. The agent sits in the middle as an orchestrator under contract. If you can't draw that graph and name the boundaries, you don't have autonomous triage. You have conditional chaos with security branding. The limiting factor: identity debt and authorization sprawl. All three scenarios hit the same wall, and it's not model quality, it's not agent memory. It's not orchestration patterns, it's identity debt. Identity debt is the inevitable accumulation of non-human operators and entitlements that your organization cannot explain anymore, but still depends on to function. Service principals, managed identities, app registrations, connector identities, delegated permissions, certificates, secrets, conditional access exceptions, break glass accounts, temporary admin roles that never got removed. This clicked for a lot of architects when agents showed up, because agents don't just consume permissions, they operationalize them. A human with broad access is a risk, but it's a bounded risk. Attention, fatigue, and work hours limit blast radius. An autonomous executor with broad access is different. It can apply that access continuously, in parallel, and without the psychological friction that makes humans hesitate. So identity debt is not accidental, it is guaranteed. Autonomy makes it visible because it forces you to name the actor. Every time you build an agent that does things, you must pick an identity, and every identity you add expands the authorization graph. New assignments, new scopes, new conditional logic, new exceptions, these pathways accumulate. This is the foundational misunderstanding. Most organizations still treat Entra as an identity provider. They are wrong. In architectural terms, Entra is a distributed decision engine. It continuously compiles policy, role assignments, device posture, risk signals, token claims, and application constraints into real-time authorization outcomes. And once you introduce agents, you're feeding that engine a new species of principle, non-human actors that behave like staff but scale like software. That distinction matters because the enterprise typically governs human identities with social process. Onboarding, role changes, manager approvals, quarterly reviews. It governs app identities with whatever happened during the project. That's where identity debt comes from, not misconfiguration, design omission. Now add authorization sprawl. Autonomous work is rarely one permission. It's a multi-step chain. Read telemetry, update a ticket, pull a file, call an API, write a config change, post a notification, verify health. Each step has a permission surface, and you have to grant enough capability for the agent to complete the chain. Over time, the safest path becomes just give it a bigger role. And that's where RBAC starts lying to you. RBAC roles tend to be static bundles designed around human job functions. Agents don't have job functions. They have task graphs. A task graph crosses roles. It crosses systems. It crosses environments. It also changes over time because the easiest way to evolve an agent is to add one more tool and one more action. So you end up with a mismatch, static roles versus dynamic execution. The organization tries to solve that mismatch with exceptions. Conditional access excludes the agent because the run broke. A resource group gets a broader role assignment because a remediation failed at 2 a.m. A connector gets tenant-wide read because a dataset wasn't available. Each exception feels small. Each exception is an entropy generator. And the real danger isn't the obvious gap. It's the ambiguity you create when the same agent behaves differently across contexts because policy drift has accumulated. Deterministic intent becomes probabilistic behavior. You can't predict what the agent can do anymore because the authorization graph has become a patchwork of historical compromises. This is why identity debt unwinds slower than it accrues. It accrues at project speed. One sprint, one fix, one temporary permission. It unwinds at audit speed. Inventory, review, reapproval, remediation, and political negotiation with every team that depends on the thing you're trying to remove. And in an agentic enterprise, the identities don't just sit there. They execute, they touch data, they change state. They create evidence trails that ironically prove the access is being used, which makes it harder to decommission because now it's critical. So the limiting factor in autonomy isn't whether the agent can plan, it's whether you can constrain execution without collapsing the workflow. If you can't express least privilege as an execution contract that maps to actual entitlements, the agent either fails constantly, so people widen permissions, or it succeeds unsafely, so you accumulate risk until something breaks loudly. That's the identity debt trap. Either you accept failure and keep humans in the loop forever, or you accept sprawl and pretend you can govern it later. You can't. So when someone asks, what does Altera really change? The honest answer is this. It forces the enterprise to operationalize the autonomy boundary as an identity and authorization problem, not a UX problem, not a chat problem. And once you see that, the next limiting factor becomes obvious. Tool access is the new perimeter, and MCP makes that perimeter easier to adopt and easier to lose control of. MCP and tool access, one protocol, many new ways to fail. MCP is going to feel like progress. Because it is. It standardizes tool access. It makes agent can call a tool stop being a bespoke integration project. It turns every SaaS system, every internal service, every local capability into something an agent runtime can discover and invoke without your developers reinventing glue code for the 1,000th time. And that's the trap. Standardization doesn't reduce risk. It reduces friction. Risk scales with adoption, and MCP is designed to accelerate adoption. So if you treat MCP as just a protocol, you will wake up with a tool surface area that outgrew your governance model. Here's the failure mode to anchor on, because it's the one that will actually happen. An agent accidentally gains the ability to delete what it should only read, not because someone flipped an evil setting, because tool scopes drift, because a connector gets reused, because a server gets upgraded, because someone adds one method to solve a legitimate business need, and the permission model doesn't force reauthorization with the same seriousness as adding a new human admin. MCP makes tool capabilities composable. Composability is how you get outcomes. Composability is also how you get privilege escalation with a paper trail. The thing most people miss is that MCP collapses the psychological boundary between data access and action execution. In a pre-agent world, a connector that reads SharePoint feels like a data integration. A connector that changes Entra roles feels like administration. Different teams, different approvals, different audits. MCP puts them in the same shape, a tool call. That distinction matters because your organization's current control model relies on friction. Separate portals, separate owners, separate change boards. MCP removes that friction, therefore your design has to replace it with enforceable intent. So what breaks first? Tool sprawl. Every product team will ship an MCP server. Every vendor will ship an MCP server. Every internal platform team will expose helpful MCP endpoints because it's easier than building a UI. And suddenly your agent runtime isn't talking to 5 systems, it's talking to 50. And each one comes with its own auth model, its own scope semantics, its own notion of read, and its own logging quality. That is not interoperability. That is an authorization expansion pack. Then you get entitlement multiplication. A single business workflow that used to require one person with 3 roles now requires an agent identity with tool access across multiple servers. Each server wants credentials, tokens, delegated permissions, app roles, secrets, certificates, managed identities. Pick your poison. And because agents are expected to work end-to-end, the easiest path is to grant broad access so the workflow doesn't get stuck. That's how delete permissions show up in a read scenario, not maliciously, inevitably. So you need 2 separate control concepts, and enterprises keep blending them until nothing is controlled. Discovery is not authorization. A registry that lets an agent find MCP servers is not a permission system. It's an index. It answers what exists, not what is allowed. If you confuse those, you've built an ecosystem where it showed up in the registry becomes the justification for the agent used it. That's backwards. Authorization must be explicit, per agent identity, per tool, per method, per scope, with evidence requirements that can be audited. And the allow list has to be enforced in the control plane, not politely suggested in runtime code. Because runtime code drifts, control planes are supposed to be the thing that doesn't. Now add versioning because MCP servers won't sit still. Servers get new capabilities, methods get renamed, default scopes get widened because a vendor wants fewer support tickets. Breaking changes don't always break the integration. Sometimes they break your safety assumptions. That's why tool allow listing can't be this server is approved. It has to be this server, this version, these methods, these scopes in this environment. Anything else is trust by branding. And the ugly part is that MCP encourages exactly the behavior that creates drift, rapid composition. You build an agent, you add a tool, you get a win, you ship. Over time, the tool graph becomes the real perimeter, because it defines what the agent can touch. So MCP doesn't replace identity debt, it accelerates it. Every MCP server you add is another place where entitlements can sprawl, another place where evidence can be lost, another place where temporary access becomes permanent because it unblocked the workflow. And yes, Microsoft is leaning into MCP hard, Teams AI library, agent platforms, Windows registries. That's not a warning that MCP is bad. It's a warning that MCP will be everywhere. Therefore, your enterprise needs to treat tool access like production infrastructure. Because in an autonomous enterprise, tools are actuators. And actuators are weapons if you don't constrain them. So if you remember one rule from this section, make it this. MCP makes action cheap. Governance has to make unsafe action impossible. Otherwise, you didn't build an agent platform. You built a fast path to conditional chaos with standardized APIs. Observability and replayability, the only cure for agent side-so. MCP makes action cheap. That means the enterprise has to make accountability unavoidable. Because once agents start acting, the failure mode isn't the model was wrong. The failure mode is that nobody can prove what happened, in what order, under which permissions, and based on which inputs. That's how you end up in the worst possible incident review, a room full of senior people reconstructing reality from screenshots and vibes. Without observability, autonomy degenerates into agent said so. An agent said so is not evidence, it's a resignation letter. So the core requirement for an autonomous enterprise is not better prompting, it's a telemetry model that treats every run like a production change, recorded, attributable, and replayable. Start with what has to be captured, not optionally, by contract. Inputs, the event payloads, ticket fields, alert IDs, file versions, data extracts, and the exact prompt instructions that shaped decisions. If the agent used a SharePoint file, you need the file identity and version. If it used a Sentinel incident, you need the incident ID and the related entity graph snapshot. If it used work data, you need the scope that defined what work data meant at that moment. Then decisions, the branching points. What class did it assign the incident to? Which policy clause did it map to? Which confidence threshold did it claim it met? Which evidence requirement did it satisfy and how? The thing most people miss is that decisions are more important than outputs. Outputs are easy to store. Decisions are where accountability lives. Then tool calls, every tool invocation with parameters. Which API endpoint, which method, which scope, which identity, which resource IDs, and the response. If an agent restarts a service, you log the resource ID, the operation ID, and the result state. If it revokes a session, you log the principal, the token session identifiers, if available, and the confirmation. This has to be structured data, not a chat transcript. Chat transcripts are theater, tool calls are facts. Then actions and state changes. What changed in Azure? What changed in Entra? What changed in the ITSM record? What messages were sent? And critically, what verification checks were executed after the action? If the contract says verify health probe green, show the probe result, not the sentence verified successfully. Finally, outputs, the human-facing artifact, the incident report, the reconciliation pack, the investigation summary. Those are important, but they are downstream. They should be generated from the run record, not written as free-form narrative that drifts away from what actually happened. Now, auditability. Audit does not care that an agent is clever. Audit cares that identity and action are linkable. Who or what took the action and under what authorization? That means your run record must tie to the non-human principal, the role assignments active at the time, and any approval objects that were required. If you can't link action to authorization deterministically, you didn't automate work. You automated liability. Cost controls also live here, and this is where most teams accidentally build infinite loops with a budget. You need to track token usage, tool usage, action volume, retries, and failure loops per run, not to optimize the model, to enforce blast radius on compute and on action. If an agent gets stuck and calls the same tool 50 times, that's not persistence. That's a runaway process. Observability is how you detect it. Control plane limits are how you stop it. And now the real point, replayability. Replayability means you can re-execute the run in a controlled environment and see the same decisions with the same inputs. Or if something differs, you can point to the exact delta, different data version, different policy version, different tool version, different model version. That is how you do postmortems without mythology. Because without replay, incident review becomes storytelling. Humans fill gaps, teams protect themselves, people argue about what the agent meant. None of that matters. The system did what it did. Replay is how you stop debating and start fixing. And replayability changes governance behavior. It forces you to version your execution contracts. It forces you to treat tool scopes like code. It forces you to notice drift. When a server update widens capabilities, replay breaks, therefore someone has to reapprove the new behavior. That is the point. So the cure for agent said so is a run ledger, immutable enough to trust, detailed enough to diagnose, and structured enough to audit. If you don't build that, autonomy won't scale because trust won't scale. Now, once you can observe and replay, you can do the next uncomfortable thing. You can compute ROI without fantasy because you can finally count outcomes, interventions, rollbacks, and policy violations as data, not opinions. ROI, without fantasy, cost, speed, and risk as one equation. Once you can observe and replay, you can finally talk about ROI without lying to yourself. Most agent ROI decks are token math and vibes. Tokens are cheap, therefore we saved money. Or time saved per employee, therefore we gained capacity. That's assistance logic. It's fine for Copilot. It's the wrong accounting model for autonomy. Because autonomy doesn't sell you better sentences. It sells you closed loops. So the unit of value isn't cost per chat. It's cost per outcome, cost per resolved incident, cost per reconciled variance pack, cost per contained low-risk security incident with an evidence bundle that survives review. If you can't measure cost per outcome, you are not doing ROI. You're doing procurement theater. Start with cost, but define it like an operator. Direct compute is the easy part. Model calls, orchestration runtime, tool call overhead. You should measure that, but you should treat it as a marginal cost on top of the real cost driver, human intervention. Every time the agent escalates, pauses, asks for approval, or fails verification and needs a human to clean up, that's labor cost injected back into the loop. And it's not just the time spent, it's the context switch. It's the seniority tax, because exceptions tend to land on the most expensive humans you have. If an agent creates more exceptions than it resolves, congratulations, you automated the worst part of the job. Now speed, and this is where enterprises keep using the wrong metric. Speed isn't how fast did it respond. Speed is queue behavior. Queue depth never goes down when the system can't close. Tickets churn, not close. Analysts become routers. Controllers become spreadsheet traffic cops. Autonomy wins when it reduces queue depth over time, not when it generates a faster first reply. So measure time to close, not time to first action. Measure throughput under load. How many incidents closed per day at peak volume with the same headcount? Measure backlog aging. How long do exceptions sit before a human touches them? And measure the shape of the distribution, not just the average, because the average hides your long tail. The long tail is where trust dies. Now risk, because this is the part that turns ROI into a real enterprise conversation. Risk isn't a moral concept. It's an operational metric: intervention rate, rollback rate, policy violations, and audit exceptions. Those are the things that make your autonomy program politically unsustainable. If intervention rate is high, you didn't build autonomy. You built a noisy assistant that still needs a person to finish the job. If rollback rate is high, your verification is weak or your execution contract is too permissive. If policy violations occur, your control plane is ornamental. And if audit exceptions appear, finance and security will shut you down, regardless of how productive it felt in a demo. This is the uncomfortable truth. In autonomy, risk has a cost curve. The first policy breach costs you credibility. The second costs you budget. The third costs you the program. So the equation you should run is brutally simple. Cost per outcome equals compute plus tool usage plus human intervention plus remediation overhead from failures. Speed equals outcomes per unit time under real load, reflected as reduced queue depth and reduced backlog aging. Risk equals the rate at which outcomes required rollback, violated policy, or produced evidence that didn't pass review. And you don't get to optimize one in isolation. If you reduce cost by lowering evidence requirements, you increase risk. If you increase speed by widening permissions, you increase blast radius. If you reduce risk by forcing human approvals everywhere, you collapse autonomy back into faster labor. That distinction matters because executives will ask, should we just buy more Copilot seats? And the honest answer is Copilot boosts individuals, autonomy boosts system throughput. Copilot makes one analyst faster at triage. Autonomy makes the queue smaller even when the analyst isn't there. And that's the only kind of ROI that survives budget season, because it shows up as fewer open tickets, faster close cycles, and fewer policy incidents, not happier anecdotes. So if you want one practical test before you show a single number, it's this. Pick a workflow where the queue never shrinks. The tickets keep coming. The team keeps working hard. And yet the backlog ages anyway. If autonomy can't change that queue shape, it's not an autonomy investment. It's a chat interface with ambition. And now that you can define ROI like an adult, you can do the next thing most organizations avoid. Decide when autonomy is worth it and when the correct answer is no. Decision framework. When autonomy is worth it, when to say no. Here's the decision framework executives keep asking for and architects keep avoiding because it forces a real answer. Autonomy is worth it when the work is repeatable, the ownership is explicit, and the system already emits enough telemetry to verify success. Not logs exist. Telemetry that can prove the outcome without a human squinting at a dashboard. That's the first gate. Second gate, the action surface is enforceable. You can name the tools, scopes, and identities involved. You can write an execution contract that the runtime can't negotiate with. If you can't, you're not evaluating autonomy. You're evaluating optimism. Third gate, you can define escalation contracts in advance. When the agent hits ambiguity, it doesn't stall silently and it doesn't improvise. It routes to a human with the evidence bundle and a proposed next action. Humans become exception handlers. If humans are still the default executor, you bought faster labor. Now, the no criteria, because mature teams say no early and save themselves a year of politics, say no when approvals are ambiguous. If you can't express who is allowed to approve what as machine-readable policy, autonomy will either freeze or bypass the process. Both outcomes are failures, just with different paperwork. Say no when data boundaries are unclear. If your org can't name which systems are authoritative and which are just spreadsheets people trust, you're going to ground the agent on the wrong truth and then argue about it for months. Finance and security will not tolerate that ambiguity. Say no when the audit surface doesn't exist. If you cannot capture inputs, decisions, tool calls, and verification as a replayable run record, you will eventually end up with agent said so in front of leadership. That's the end of the program. And say no when nobody owns the pager. Autonomy shifts ownership. It doesn't remove it. If the failure mode is everyone is responsible, then no one will fix the control plane when it drifts, and the agent will inherit a decaying policy model. So the maturity gates are simple. Identity readiness. Can you issue non-human principles with narrow scopes and lifecycle controls? Tool registry readiness. Can you enumerate and allow list what exists versus what's allowed? Evidence readiness. Can you produce replayable runs that survive postmortems and audits? Now, human-in-the-loop design. This isn't about feelings, it's about thresholds. Define explicit confidence thresholds per action class. Define evidence requirements per incident class. Define what triggers elevation, what triggers approval, and what triggers escalation. Don't let human in the loop become a permanent crutch, and don't let full autonomy become a marketing goal. The autonomy boundary is a control surface. Treat it like one. And the operating model is the part most orgs skip because it's boring and political. Who owns agent failures? Not the dev team, not AI, the business owner of the workflow. Who owns policy changes? The team that owns the control plane, with change control like any other enforcement system. Who owns the tool scopes? The tool owners, with versioning and reapproval when capabilities change. That's the framework. If it sounds strict, good. Autonomy is strictness automated. Implementation payoff. The 30-day autonomy pilot that doesn't embarrass you. If you want a 30-day pilot that survives contact with reality, pick one domain. IT remediation or security triage. Don't run 3 pilots in parallel and call the confusion learning. Write 3 policies on day 1, allowed actions, evidence requirements with confidence thresholds, and escalation paths with named owners. Stand up evidence before you stand up autonomy. Action logs, tool call capture, and replayable run records mapped to your audit expectations. If you can't replay a run, you can't defend it. Then measure the only metrics that matter. Time to close, MTTR delta, human in loop rate, rollback rate, and policy violations. If those don't move, stop. Don't rebrand. Autonomy becomes safe only when it's enforced by design, through the autonomy boundary and execution contract, not by intent or good luck. If you want to test readiness this week, do one thing. Remove one human step from a workflow where the queue never shrinks, but add one hard boundary that the agent cannot cross without evidence and policy. And here's the line that should end the discussion fast. If you can't name who wakes up at 2 a.m. when the agent fails, you're not ready for autonomy. If you've got a workflow where tickets churn and nobody can close the loop, put it in the comments. And watch the next episode, because we'll go deeper on agent identities, MCP entitlements, and how to stop conditional chaos before it becomes policy drift.